Let us start today's session. Very good evening to one and all present here. I myself, I'm V. Dhanush. I'm a student from fourth semester studying in the Department of Electronics and Communication. And today I'd like to welcome you all to the pop-up course on Ethics in Engineering Practice. So let us get started. And before introducing what is my agenda, why I really wanted to conduct this meeting and share the information which I have acquired, I have taken a small quiz during the registration itself, which says, which of the following do you think contributes to the progress of a nation? Well, I have specifically made you to choose only three choices, the top three choices. See, the choices which were given was institutions, maybe like courts, law enforcement societies, or educational institutions, etc. Cultural heritage and diversity, robust awareness and consciousness among citizens, ethics among individuals and organizations, physical and mental health, strong and unbiased media, infrastructure development, and strong social movements. Basically, the answer is these all parameters are very important for the contribution. These are not the only parameters. There are even more. But if you just cut down to few things, and if you think logically, the top three choices, what are most important things? Well, for cultural heritage, or for health support, or for a media, or for infrastructure development, or for education, anything, institutions institutions are made by people, and this is one of the most important factor. Without institutions we cannot do anything. For example, RVC, without the college we cannot be able to study. These are all institutions which provide us some facilities, some services, etc. These are the first most important thing which is required for a nation. And let us see the second one. We have got majority for ethics among individuals, and followed with institutions, and then followed by infrastructure development. Well, now if we see that for any institution or for any movement, the first and foremost important thing is awareness among the citizens. Without awareness, no scheme or anything, you cannot literally get the advantage out of it, basically. If you're not aware of what's going on, and if you're not conscious of what's happening around you, it is probably almost impossible to know what's happening. You cannot avail the benefits of that scheme, etc. Now, let us see the other important thing is ethics among individuals and organizations. Well, no institution can stand for a long time without ethics among their individuals. This is very important parameter, and with this, I would like to introduce the agenda of this pop-up course is to make each and every student ethically conscious and aware about this course. Now, what do you mean by ethically conscious and aware? Basically, awareness is nothing but you just knowing stuff. Yes, I'm aware of it. What happened in yesterday's news? Did this incident happen? Yes, I'm aware of it. But there are some situations where we always tend to overlook them and ignore them. Well, and in these situations, one must be ethically conscious and exercise his or her duties properly. So this is our agenda, and let us start our session. Well, this person over here is Herbert Hoover. Anybody can guess who is he? Can we have someone from the audience to just take a small guess? He's definitely not an Indian, but any guesses? You can even use the chat box. No worries. I'll just tell you. He is the 31st president of USA. And initially, he was an engineer. After that, he became a politician. He was a businessman also. And then finally, he became the president of the country. Well, we have a big statement over here. Can somebody from the audience volunteer in reading out this statement, which was quoted by Herbert Hoover? Can we have someone from the audience, especially from the first year at least? Or second years, anybody can volunteer. It must be an interactive session since we are having 45 minutes of presentation and 15 minutes at least of interaction. Can we have someone from the audience? Let us see. We have, okay, Abhirami. Abhirami, could you just read out this statement for all of us?
Yeah, sure, Dhanesh. The greatest liability of the engineer compared to men of other professions is that his works are out in the open where all can see them. His acts, step by step, are in hard substance. He cannot bury his mistakes in the grave like the doctors. He cannot argue them into thin air or blame the judge like the lawyers. He cannot, like the politician, screen his shortcomings by blaming his opponents and hope that the people will forget. The engineer simply cannot deny that he did it. If his works do not work, he is damned forever.
Thank you, Abhirami. So as
Yeah.
you can see, yeah, so as you can see, Herbert Hoover has said that engineers' works are out in open. I mean, we are talking about lawyers over here, we're talking about doctors, we're talking about politicians, a lot of people. But if you see, if you observe clearly, the works of engineers are out in open. For example, take for example work of a doctor. Well, doctor works inside his ICU or etc. But you cannot actually go and visit and see what's happening. Lawyers, again, we're not trying to tell that these professions are bad, but comparatively, if we observe, engineers' works are out in open. If an engineer makes any mistake, he must be taking the final responsibility, because if a case is lost, most of the times lawyers get free. And even if sometimes a person passes away, the doctors cannot take the blame on themselves. And politicians, you definitely know the scenario around. So the engineer simply cannot deny that he did it. If his works do not work, he is damned forever. With this statement, we proceed. Well, before that, I would like to ask you, Herbert Hoover was an engineer and he became the president of USA also. However, this throws light onto another famous personality in our own country who was an engineer, a scientist, and then further became a president. Any of you, any guesses? I think it's an obvious guess. Anybody who became the
Dr. APJ
president?
Abdul Kalam.
Excellent, excellent. Whoever has told that. Absolutely. Let us have a brief look at engineers from India. It's not like engineering is a new profession to our country. Engineers existed since a long time, although there were few initially, but still we had engineers. Well, this is Dr. APJ Abdul Kalam. He was born on 15th October 1931. He was a notable engineer, a scientist, and served as the 11th President of India from 2002 to 2007. He was awarded Bharat Ratna in 1997. He was known as the Missile Man of India, also called as People's President. The reason I'm showing all of these is to provide some inspiration to the audience regarding the profession of engineering
Hello, Dhanush.
and engineers themselves. Hello?
Dhanush.
Yes, ma'am. Good evening, ma'am.
Yeah, good evening. Sorry, I just came late. I wanted to welcome you for this pop-up and introduce you to the audience. I think it went the other way around. I'm very sorry. My dear friends, I was held up in a meeting till now, so I could not join you on time. Nevertheless, it is very, very appreciable that Dhanush of fourth semester have come forward to deliver this pop-up course today. One particular thing what I want to tell about Dhanush is he is very enthusiastic, very, very keen observer, and always on upfront to lead the issues or the voices of all the students. Okay, and what I have observed in him is the kind of diversified thoughts what he has. So those things are really appreciable at that age itself. So it's a long way for Dhanush to go again. It needs little bit of focusing and hope that his initiatives are focused so that all the fruits are given to him. Let God bless him with all these things. It's really wonderful, Dhanush, your gesture for accepting this talk and trying to talk with the other students, your peers, as well as your seniors, as well as your juniors. I understand that there are more than 60 participants today. It's really good to see that students are enjoying this kind of sessions wherein they can listen from your own peers and your own seniors or juniors. It's a student activity which is really going on in a right way, and I would require more and more students to come forward and take it up this in a larger spirit.
Sure,
So
ma'am.
very nice of you that you have come forward for this. Hope
Thank you, ma'am.
everybody
Thank you.
enjoys your talk, and all the best for you, Dhanush. Thank you.
Thank you, ma'am. Thank you for giving the opportunity also.
Yeah, thank you.
Well, thank you, HOD ma'am. We'll just continue with our session now. Hope you'll all enjoy it. Again, as I said, the purpose of showing all these things is to provide the audience an inspiration about the profession of engineering and engineers themselves. Now, he is a very famous character. I should have actually put this up front, but I put Dr. APJ Abdul Kalam because I could, make out the slides. Now, Sir Mokshagundam Visvesvaraya. Sir Mokshagundam Visvesvaraya was born on 15 September 1861. Bear with me for the next 3 slides. They are going to be these things, but I felt that if we start a session with taking the names of these people, this will provide an inspiration for each and every audience around here. He again was a notable engineer, a scholar, statesman, and the Diwan of Mysuru from 1912 to 1918. He again was awarded Bharat Ratna in 1995. Engineers Day is celebrated in his memory. I hope all of you know 15 September is celebrated as Engineers Day in India as a memory of Sir M. Visvesvaraya. Well, there's one statement that Sir M. Visvesvaraya has made, as you can see. The way to build a nation is to build a good citizen. The majority of the citizens should be efficient, of good character, and possess a reasonable high sense of duty. Again, with this statement, we carry our inspiration to a greater level about this course. Then, anybody can anyone from the audience guess who this character is? Who is this famous personality? Any ideas? Any guesses? Well, anyways, never mind. He is Dr. Satish Dhawan. I think he's famously known for the Sriharikota launch center, which is located in Andhra Pradesh. Dr. Satish Dhawan was again born on 25th September 1920. He did a double PhD in mathematics, and he was an aerospace engineer too. He was known as father of experimental fluid dynamics research in India. Now we'll be starting our session basically. How engineers view themselves. Of course, we are all engineering students right now, but we will be the future engineers. Let us just have a brief glimpse of how engineers view themselves and how public views the profession of engineers, the profession of engineering at large. Well, engineers view themselves as problem solvers. Engineering is enjoyable. Engineering benefits people and provides public service. And as I again said, engineering provides the most freedom of all professions. Because a doctor, a lawyer, or anybody else cannot do as many experiments as an engineer, because an engineer can simply tell the excuse of, I'm doing it for the greater goods. Whereas a lawyer, he cannot go beyond the law. A doctor cannot do more experimentation on any patient simply because of the fact that it can harm the patient. Again, engineers view the profession of engineering as an honorable profession. Now, the most important thing is how the public views engineers and engineering. The public views engineers as utilitarians. Well, I'll bring this term at almost the end of the seminar. You'll probably understand what utilitarian is and what is utilitarianism. Now, they also say that engineers are positivists, applied physical scientists, someone who can convert technology to their benefit. Rational, logical, and systematic approach to problem solving tend to alienate the engineer from public due to technicalities. Isn't it true? I think, if I'm not wrong, there's a common notion saying that either you'll become an engineer or you'll become a doctor. I mean, it probably exists even now. But you know what? Compared to even the profession of a doctor, you can say that engineers basically are alienated from the public because just because of the fact that people think that engineering is so difficult, it involves a lot of things. Oh my goodness, I guess you guys would have understood what I was trying to say by now. Now, let us get to this slide. National Society of Professional Engineers. What is this Professional Engineers National Society? It's basically an international organization which is made by engineers and for engineers. All right. It's known as the National Society of Professional Engineers. Now, what can we see from the preamble of this NSPE Code of Conduct for Engineers is the primary obligation is to protect the safety, health, property, and welfare of the public. Please, if you're there on your phone or laptop, take a screenshot of this because the whole course basically revolves around these 3 points, which I have put up over here. The entire course could be understood just by this one slide. Primary obligation is to protect the safety, health, property, and welfare of the public. Engineering occurs at the confluence of technology, social science, and business. You may ask, what is the role of social science and business in engineering? Well, you'll get to know in the upcoming slides, but let me just give you a glimpse. Technology, of course. We all need to know how things are made, and after making the things, you just simply cannot say that I cannot sell this, right? You make things so that it can be used by the people and it cannot be given out for free. People must buy it. People must buy your product. Now, in order to buy your product, there are again so many rules. You have intellectual property rights. You have a lot of things that your product needs to go through before going into the market. You need to cross-check at each and every stage. You need to make sure that whatever you're doing is ethical, it's intact with the law, not just of the nation, but throughout. We'll also see some examples in the next slide. Now, it is important for engineers to make sure that the interest of the groups to be affected prevails over their own interest of profit. What does this mean? This means to say that engineers and their works must make sure that benefit goes to the public. They must not be greedy and make sure that only they benefit from the profession of engineering. Throughout this whole course, we will be discussing about a lot of case studies, a lot of ethical dilemmas, code of conduct, whistleblowing, role of engineers, responsibility of engineers, and leadership, etc. But throughout this course, I want to tell that these 3 points are the major highlight of this course. Okay. Now, what is engineering ethics? Well, Martin and Schinzinger say that, well, these were the ones who formulated and proposed engineering ethics initially. They have also written a book on engineering ethics. Those interested can, those interested can go through them. Now, they say that engineering ethics is nothing but the study of moral issues and decisions confronting individuals and organizations involved in engineering. Well, you may say that why is engineering ethics important to me, and I'm just a student, Well, it's a busy world, and we do not have much time actually. We have probably, if you're a second year student, you have 2 more years at RVCE. After this, what's going to happen is you are all going to be engineers in one way or the other. You may be a civil engineer, you may be a mechanical engineer, you may be a software engineer, but engineering ethics it prevails everywhere. And basically, ethics is not just in engineering. Even doctors have their own code of conduct, their own ethics. Lawyers also have their own ethics, but still, we will be studying about engineering ethics. And believe me, this will be an insightful session for everybody, at least for those who are attending. You guys are lucky to have the case studies which we are going to be discussing today. Okay. Now let us see what are the impact of the decisions made by engineers. Well, as you see, engineers are basically responsible for providing services by using whatever their technical knowledge, etc. We bring a lot of designs, we bring a lot of products, and we provide a lot of services. Well, in order to do all this, there are lots of checks and balances which an engineer must maintain. And if the limit is crossed, it may affect entire globe also. I'll just show you the real-time examples in a minute or two. But just look at these, the products and services. First of all, engineers must make sure that their products is easily usable and is safe for the consumers. The company and its stakeholders, definitely. If you find a product to be, sort of not good, it affects the whole company and its stockholders. Stockholders are basically those who hold shares in the company, and that if a product is not good, you will dump it, and the company itself can go to loss. Now, the public and society. Well, this can go in two ways. If your product or your service benefits the people and assures them safety and trust, it builds the profession itself. It builds the image of the profession. It builds the engineering concept itself. A lot of people will be attracted towards it. But just in case, if there's something happening, if there's a flip-flop, if there's a, sort of, how do you say, if there's something bad or wrong which has gone, the public will really get a bad image about the profession of engineering. It again involves environment also. We'll discuss this in the third session. The law, basically laws are not made everything firsthand and then followed. There are a lot of laws which are made after a lot of incidents. For example, the Bhopal gas tragedy, the Satyendra Jit case. There are a lot of cases which really impacted the formation of laws. You will probably get it in the second session. And personal position also. The way you behave, the way you maintain your position is also really impacting thing on the decisions which an engineers make. Well, let us see what are engineering tasks and possible problems. You can see there are so many tasks which the whole process of engineering defines. We see that we have conceptual design. Basically, what are these things? What is this nonsense he's coming up with, you may say. But let me just assure you that these are the tasks which every engineering profession and which every company must go through in order to finally deliver the product or the service. Conceptual design. What can be the possible problems? Well, the engineer may be blind to new concepts, violation of patents or trade secrets. Again, patents, trade secrets, all this will be discussed in the next session. And sometimes the product may be used illegally too. So the engineer must be very conscious, as I said in the previous slides, Engineering occurs at the confluence of technology, social science, and business. He must be aware about everything that is going on in order to make sure his product is being utilized by the public at large. Goals, performance specifications. Well, let us see what is this. Unrealistic assumptions. Well, design depends on unavailable or untested materials. Now, what this means is that your goal is to finish the project within, for example, 1 month. You cannot build a bridge within 1 month, and if it is rushed, I'll just tell you the consequences in the next slide. We'll be having lots of discussion based on them. Next, preliminary analysis, detailed analysis. Well, these analyses are nothing but methodologies which a designer uses in his area of expertise. Simulation, prototyping, design specification, scheduling of tasks, purchasing. What are all these things again? Now, one needs to again check the design properly, check the design twice, scheduling of tasks, as I said, promise of unrealistic completion dates, which is due dates, purchasing. Now, in this category, we have lots of things like bidding, competitive bidding, and a lot of things which engineers are not supposed to do. So, for example, the specifications are written to favor only one vendor and taking bribes, kickbacks, etc. Fabrication of parts. Now, what does this mean? Variable quality of materials and workmanship, bogus materials and components not detected. Well, it's the duty of an engineer to make sure that his products are of perfect quality. If not perfect, at least the best quality. It must not be like some malpractice which is going on where you mix 50% of the good material and 50% of some cheap material. Advertising and sales. This is the biggest thing which not just engineering profession but media, the government, everybody are come under this scrutiny. Advertising and sales. See, false advertising is becoming a big problem nowadays because see, if you just for example open any lace packet or just see, you can see that the lace packet looks very good from the outside, but inside we'll find a lot of defects. I'm sure all of you would have faced this problem. Well, it's of course not an engineering defect, but I would say it's an advertising defect, and that's probably the reason why they write with a star symbol saying that the product inside is not exactly as the product outside. You would have seen those statements written in these things, usually. So false advertising must not be done, and there are a lot of parameters again: shipping, installation, and training. So if product is too large to ship by land, so installation and training subcontracted out. That means you need to again do shipping via water, and again a lot of things come in. Mechanical engineers play a huge role in shipping. Believe me, mechanical engineers are not only the ones who work on land, they work on waters too. Safety measures and devices. Now, that means if the product is over complex and it has some, failure prone problems, and there's simply a lack of safety exit. That means if I do something and if it goes wrong, there must be some backup. It must not burst out. For example, I have a light. See, basically there's a fuse which is meant to make it safe, even if there's a large amount of power which is driven inside the tube light. That's what it basically means. And use. Well, this is a very complex topic. If it's used inappropriately or for illegal applications, then it's of a very bigger massacre. For example, it's not just we who will be using. Engineers must make sure that there can be nothing which can go wrong while using it, and if it falls into the wrong hands, we'll also study about nuclear ethics, etc. And finally, maintenance, parts, repairs. So if there's an inadequate supply of spare parts, and if there's a hesitation which is leading the product which is to be found faulty, etc. Anyways, these are not too important, but I'm just trying to say that go through these things because these are all parameters which we'll be judging ethical situations upon. Let us see. This is a small example, a real life example. What does this say? You can see a bridge over there. So a newly constructed bridge collapses near Ranchi, allegedly due to illegal mining. Well, engineers work in mining sector also, but it's not about that basically. If you see over here, first of all, it's a newly constructed bridge and it has fallen down, it has collapsed. Well, what could be the problems behind it? Well, you have a lot of parameters again. It can be because maybe the project was pushed so fast that they couldn't do proper testing. Proper testing wasn't done, and they haven't probably even checked. And see, as I said, there's a preliminary analysis and there's a detailed analysis. Well, even though the preliminary analysis was fine, they might not have found time because of unrealistic targets, unrealistic due dates, etc. So the newly constructed bridge has collapsed. Well, it may be due to illegal mining, but the problem is it's a newly constructed bridge. Engineers must take the responsibility in such cases. And believe me, in future, of course, civil engineers will be playing a huge role in the infrastructure development. But if anything goes wrong, it's finally the engineer who must take the responsibility. The politician will go. He'll only be there for 5 years. Even by law, you cannot blame the politician for all these things. Finally, it's the engineer, a working official, who must take responsibility for all the mistakes caused due to any project. Well, this is a very interesting case, out of control Chinese rockets falling on Earth. This it wasn't long, maybe 1.5 months ago. This rocket's name was Long March 5B. Okay. Basically, what happened was this rocket was launched from China. It was supposed to go out of Earth. It was supposed to go in the space and revolve around the Earth and do its work. But what happened? Long March 5B successfully it went up. But what happened is after a point of time, it just did a rotation. It rotated and it was falling back on Earth itself. Well, I don't know how many of you have heard this case. Could someone raise your hands in the meeting saying that you know about this case? Basically, did anybody know about this event? Nice, Prajwal, you know about it. Basically that time, when even I saw this, the only thing which was in my mind is, oh my God, just make sure that this rocket doesn't fall anywhere on me or near us. Well, quite a few people have heard this. I know, right? See, now what happens in such cases? All of us get panicked. This is the first thing which happens, and it's not just us. Anybody who probably goes through this news, they will get panicked and they'll start going wild. Although this time the pandemic was a bigger problem, hence this issue wasn't taken enough note. Although, see, this is what happens. There are a lot of problems, and this is a big scale, how to say. Engineers or scientists, basically scientists are mostly engineers itself, who dedicate their life more to research and development. So engineers, these guys, what could be the problem again? We never know. But one thing is, if a project is being constructed on such a big scale, imagine the amount of security parameters, the amount of testing, the amount of simulations which must be gone through before launching it. And if this doesn't happen properly, we can meet catastrophic results. This time, thankfully, the rocket fell into the Indian Ocean. See, over here, we are not trying to say that we're not trying to blame any country, etc. But we are trying to say, see what happens if ingenious, due to ingenious decisions. Well, it's finally the engineer who has given a go ahead, right? So that's what I'm trying to say. And see, this not only brings criticism from the public, but it brings criticism throughout the entire nation. Uh, I'll just show you a video. Just a second. Share this tab. Oh, okay, fine. Go through this one. See, the Chinese rocket debris falls into Indian Ocean. If I'm not wrong, you might not get any audio over here, but just go through the video. In between, you'll see the criticism faced by the country because of this incident. See what this person has said. He's a NASA administrator. He said that spacefaring nations must minimize the risks to people and property on Earth of re-entries of space objects and maximize transparency regarding those operations. Basically, all he means to say is keep up the engineering profession. It is meant for the safety and welfare of the public. Well, that's precisely what he meant to say, although there are a lot of things in it, a lot of parameters. He said that spacefaring nations must minimize the risks to people and property on Earth. That means spacefaring nations are nothing but nations who have who are technically advanced in launching things to the space, which is again ingenious itself, right? Nation means it's made up of people, and who deal with all these things is nothing but engineers. Engineers must minimize the risk to people. And this event faced a huge criticism, and because of which, again, China had to take another, blame on their name. So see what can happen because of engineering faults. It's definitely a fault. You cannot say that, "Ayo, Papa, he would have done a small mistake." That's not acceptable in these situations, because imagine if it would have fallen on some apartment or something. It could have been real. The results could be really catastrophic. Although thankfully this time it fell into the Indian Ocean. It says the importance of testing, etc. Okay, let us get back to the presentation. So you have observed what are the impacts of, as I said in the previous slide, you have seen a glimpse of engineers' ethical decisions that have a far-reaching impact. Well, you have already seen that how it impacts the public and society and the entire nation, of course, by this incident. Well, let us now go to the next slide. Okay. Today, we are going to discuss two case studies. This is the first case study. Believe me, these case studies are the most important things of the entire course. See, this is a theory course basically. It's not a practical, where you can solve any numericals. It's a theory course whose applications will be used in real life. So these are the case studies. What is a case study? A case study is nothing but a story. It's a simple story which happened in real life. Why are we studying it? We are studying it because this case study gives us lots of observations and conclusions. Let us get started. What does it say? You can see, mistakes made by engineers can be costly. Case study. The Thirac 25 X-ray machine. What can you see in the image? You can see a sort of computer which is linked to a machine which uses X-rays for treatment of its patients. Let us go through what the case study is. Believe me, the case studies are very, very insightful. You'll probably have to concentrate the most in this part. Yeah. Let's get started with the case study. Lethal treatment, the Thirac 25 X-ray machine. I request each and every audience just to follow what I'm reading and look at the screen. The Thirac 25, a radiation therapy machine, killed or injured several patients at North American healthcare facilities between June 1985 and January 1987. When the technician operating the Therac 25 made a typographical error, read the thing very carefully. When the technician operating the Therac 25 made a typographical error in entering instructions and tried to correct this mistake by using the delete key, the filter on the machine dropped out of position. Basically, this X-ray machine has a filter, which is nothing but it's like a fuse. It's like a safety device, which happens when a lot of X-rays pass through the body. So the filter on the machine dropped out of position. The result was that the patient undergoing the radiation treatment received a massive dose of X-ray. Several patients were injured or killed as a result, even before it was realized that the machine was dangerously defective. The Therac 25 had been poorly designed and inadequately tested. Read the statement very carefully. The story is a complicated one that highlights many subtle as well as gross mistakes. In particular, the design and testing of the linking of the hardware and software were totally inadequate. Competitive machines had a shield. See, basically these competitive machines are nothing but X-ray machines, etc. They had a shield that would engage if the power rate went at a high level. But what happened in this case? In this case, the filter itself has fallen down. It didn't work. Furthermore, management decisions in the face of evidence of safety problems varied from short-sighted to negligent. It means to say that it was not short-sightedness, it was sheer negligence. The manufacturer, which is the AECL, Atomic Energy of Canada Limited, had many problems and had since gone bankrupt. You might not have understood this reading the first time. Let me just give you a small explanation of what happened. The Therac 25 X-ray machine. So this basically, there was one hospital in Northern America, healthcare center. In this hospital, the hospital had bidded for some X-ray machines, especially the Therac 25 X-ray machines. So that day what happened was, the person who operated the machine, if you can see me over here, I'll just take the pointer, turn on the laser pointer. Yeah. Somebody has joined. Okay. If you see over here, now there's a delete button somewhere over here. So this person who has operated initially typed something else. He typed some other program which would make this machine do something else. And then he realized his mistake and he pressed the delete key. The delete key is over here. He pressed the delete key. As soon as he pressed the delete key, what happened was, the filter which was supposed to be there on the X-ray machine had come down. It totally was a disaster between the linking of software and hardware. What happened exactly was, I'll just tell you the real story over here. The hospital people chose a vendor and they wanted a lot of machines in a very small span of time. So what exactly happened because of this? Engineers had to rush to make the machines. In this rush, what they did was, they totally ignored the fact that, what if the consumer presses a wrong button? What if he doesn't go in the right direction? He ignored all these facts. All he was thinking in his mind was, he designed the software only in such a way that only if you type the right thing, it will do the work. If you type a wrong thing and press the delete button, he never tested that exactly. As you can see, the operator made an error at the start of the treatment in the configuration of the machine. Later, he rectified the software of the machine. But the user interface, that is nothing but the screen, it reflected that everything was going on well. And it really didn't give him any indication that the filter was dropped down. But it allowed to continue in the operation of the radiation. The patients received radiation up to 125 times higher than what had been configured. So this is basically the the story of what happened in the Chirac 25 X-ray machine. Now, the main problems in the development of this software had been the following. The programmers did not assume that the operators could make a mistake in the configuration and would have to reconfigure the machine. They only assumed that the operator would never make a mistake and always would go in the right part. For example, hash include stdio.h. You have to type that only first. What if I type something else and then press a delete button? No, he only thought we'll only go in this flow so that he will finish the software very fast, designing the software. No tests of any kind were developed. That is, the software was only tested by them in the cases of successes when they were developing it. This is again a very big defect. It's a clear case of negligence and totally unethical to do so. Just because the company wanted to earn money, they rushed the entire project of making the X-ray machines, especially in the health sector. And this is what costed. Lots of people's lives were taken away and lots of people were injured due to the X-ray radiation. Now, because of this, what happened was there was a commission which was set up by the state, and the conclusion of the commission was the following. AECL did not have the software code independently reviewed. This is very important because, see, testing should not only be done by your own people. I mean, what's the point if you only do the thing, you only test it, you only certify it, you only give it out? There must be some other agency which must review your product. Until unless that is done, there cannot be any sort of safety standards that can be provided. You must get it checked by someone else. I mean, you cannot write the test paper and correct it yourselves, right? That's totally unfair. Now, the AECL also did not consider the design of the software during its assessment of how the machine might produce the desired results and what failure modes existed. They basically only tested the things which were favorable to them. This is again a very, very big mistake. Although as engineering students, we, even during surveys, right, we ask only questions which are very, very, favorable to us. For example, the DTL survey, etc. What we did, we chose questions which were almost, of course, some have done very nicely, but even we did the mistake. We also chose the questions which were very, very favorable to us, which could bring the conclusion very softly, nicely. But this is not supposed to be done. Now, AECL personnel as well as machine operators initially did not believe complaints. This was likely due to overconfidence. Now see, this issue was reported to the personnel, meaning the people working in the company, but still they have not believed these complaints. Although there's a defect, one must take responsibility, accept and again review of what has gone wrong. This again has not been done by the engineers. AECL had never tested the Therac 25. This was the final conclusion. Had never tested the Therac 25 with the combination of software and hardware until it was assembled at the hospital. See, they haven't tested till it came in the hospital, it seems. This is what is the problem basically. I mean, if it's an engineering student, it's not a problem, but it's an engineer over there who is supposed to supply the kit to the hospital who will be using it to treat patients. It's totally unfair, it's unethical, and engineers must remember this. See, if a project is given a very short deadline, one must, at least engineers who are in the managerial role, must oppose to it, because he or she would know that, no, I cannot finish it within this due date. It's practically impossible. They must oppose things. Well, this is where whistleblowing and a lot of things come. So we'll be studying it in the further sessions anyways. Fine. I hope the first case study was somewhat insightful, and see, it's a real thing. It happened. Okay. So I have gone through the first case study, but in the second case study, I would request the audience to provide what they have observed throughout. Anyways, let's get to ethical theories. What are ethical theories? These are basically some sort of theories which are used to evaluate the ethical aspect of any action or situation. Believe me, these are very useful theories. It's not only in engineering that we use it, you can use it in anywhere. Although there are dozen of ethical theories, these four are the most fundamental ethical theories. Any situation, need not be an engineer, it can be a doctor, it can be a student also, they can apply these ethical theories and find out whether whatever they're doing is ethical or not. Utilitarianism. What is utilitarianism? As I said, in the initially we have seen how public sees engineers. Public sees engineers as utilitarian. That means, let us see what is utilitarianism first. Utilitarianism holds that those actions are good that serve to maximize human well-being. Here, maximizing the human well-being of society is at more priority than individual benefits. There are again two types of utilitarianism. I would just simply tell what are those: act and rule. Basically, act utilitarianism says that actions are very important. For example, being honest, not stealing from others. These are very important than to follow the rules. The second one says that no. Rules are important. First, follow the rules, then only your actions. Let us see let us see a small example of the view of utilitarianism. For example, a dam is being built. Well, it has its own plus points and minus points. What happens? It provides a lot of benefits to the entire state. That means it's of a great benefit to society. Why? Because it provides drinking water, flood control, power generation, and recreational activities. Also, it provides water for irrigation purposes as well. But on what cost is it happening? It happens, see, these benefits often come at the expense of people who live in surrounding areas, whose land and homes will be flooded by the dam and would require to struggle to find new homes, employment, etc. As you can see, in basically the construction of a dam is defined ethical in our country. The reason is because they consider the utilitarianism theory that states that, okay, although there are a couple of hundreds of people which I need to migrate from this place, but what are the outcomes of it? It benefits crores of people. So this is the view. If it is going to benefit a lot of people, and if its effects are really beneficial for a majority, then you can say that the action is ethical. This is what a utilitarianism holds. Now, what is the criticism of utilitarian approach? See, you cannot decide what is the best for everyone, because what is good for one person or a group of person can be bad for someone else also. I'll give you a small example. Imagine a room. Imagine a room of 4 people along with a doctor. I'm sorry for the thing. A room with 4 people and a doctor. So, yeah. So these 4 people, among these, among these 4 people, 3 people are suffering from some problem. Maybe one person is suffering from heart problem, one is suffering from kidney problem, one is suffering from liver problem, and the 4th person is healthy, wealthy, and wise. For example, so what do you think? I mean, is it good that if the doctor takes out heart, liver, and kidney from the healthy ones, from that healthy guy, and gives it out to the other 3 people respectively, and makes the 3 survive? In this case, what is happening is you are taking the essentials of one person and giving it to the other at the cost of the death of one person, because the healthy guy will die and the other 3 will live. Utilitarianism states that this act is ethical because it only sees the majority, what will be good for the majority of them, but it ignores a lot of things. For example, what is happening over here? 3 people will be surviving but the fourth guy will die because of these three, because of saving these three. Well, the fourth guy also has a right to life. You cannot do that. This is what rights ethics holds. I'll anyways get back to that again. Now, another objection of utilitarianism is that its implementation depends greatly on knowing what will lead to the most good. Most of the times, it's impossible to find out what exactly will lead to the most good. For example, dams. See, dams are great benefit to the society, but it's not only people that will be having to vacate the place, but it's also lot of biodiversity, lots of flora, fauna, etc., which will have to be sacrificed. Lot of important microorganisms, etc., which will be killed because of the construction of a dam. All these parameters are not taken into consideration. So how can we say that this is the best thing and etc.? So these are the criticisms of utilitarianism approach. Let us see what is duty ethics. Now, the proponent, this Immanuel Kant, had proposed this ethics. He says moral duties are fundamental ethical actions like be honest, be fair to others, don't steal. All these things are, sort of duties. It's like a good, a disciplined soldier. He should be very honest. He should be fair to others. He shouldn't steal. He should always speak respectfully, etc. So they say that if you put all these actions in a piece of paper and follow them properly, it is ethical. So he says that once one's duties are recognized, the ethically correct moral actions are obvious. Hence, ethical acts are a result of proper performance of one's duties. Next, we have rights ethics. It was formulated by John Locke. What does he say? He says that humans have the right to life, liberty, and property. I think we have discussed this in the 4 people in a room with a doctor case study, a small example, right? So he says that rights ethics holds that people have fundamental rights that other people have a duty to respect. Meaning, bhaiya, I am having some rights which you have a duty to respect. You should respect my rights. I should respect your rights. So if you take rights ethics, you have to debunk the 4 people in a room theory. Utilitarianism no longer can take place. Rights ethics clearly states that it's unethical. You cannot take away the life of one person to save the life of 3 people. I mean, it's totally. I mean, imagine if you were the one person over there. That only then you can tell about this. Criticism of both these things is that the basic rights of one person may conflict with others. Definitely. See, those 3 people had a right to life, okay? But so does the 4th person has a right to life. This is a clearly hypothetical situation, but most of the times it comes in nuclear warfare and in the army. These approaches are used even in the army. So, these theories don't always account for the overall good of society very well. We'll discuss about it in more detail throughout the session also. Virtue ethics. Please pardon me. I would like to take a couple of more minutes to, get to the conclusion of today's session. Virtue ethics. What does virtue ethics hold? It says that you are a good boy or a girl if you have these virtues. You're not good if you don't have these virtues. If you're having all these vices. Virtues are responsibility, honesty, competence, loyalty, trustworthiness, fairness, caring, respect, etc. Whereas vices are dishonesty, loyalty, irresponsibility, incompetence. I think all of the Indians are born with all these teachings. So I don't think it's necessary to elaborate more on this. Right. Take, for example, a chemical plant near a small city that discharges a hazardous waste into groundwater. If the city takes its water from wells, the water supply for the city will be compromised and significant health problems for the community may result. See, there's a chemical plant, okay? it is giving employment to certain amount of people over there. But at the same time, it's producing a lot of pollution. Let us evaluate this situation, this scenario, using the ethical theory. The rights ethics says that pollution is unethical since it causes harm to many of the residents. So definitely it's a violation of rights ethics. Whereas a utilitarian analysis would also say that since the economic benefits of the plant would almost certainly be outweighed by the negative effects of pollution and the costs required to ensure a safe water supply. This means to say that how much ever amount the company is earning, the chemical plant is earning, that will be far less than what will happen if all the population of the state gets sick. They must go to the hospitals and spend lots of money. That money will be more than what the company or the chemical plant can produce. So even the utilitarian approach says the same thing. Whereas virtue ethics would say that discharging waste into groundwater is irresponsible. As I said, rights ethics deals with rights of people. Utilitarianism deals with, okay, which one, if you put on a weighing machine, which one will weigh more? Based on that, I'll take the decision. Whereas virtue ethics says, is it responsible? Is it, is it honest? Is it all these things? So it is irresponsible and harmful to individuals, so it shouldn't be done. In this case, all the ethical theories lead to the same conclusion. Hence, the stopping of the chemical plant is for sure. But in real life, there are a lot of situations where all ethical theories will not lead to the same conclusion. What should we do in that case? There are something known as code of conduct, which we'll discuss in the next session. Finally, to end today's session, I think we have less audience, but I would like to end the session with this case. It's a classic case study, which is nothing but the Aberdeen 3. So this is the most popular case which is studied worldwide. Pardon me, I'll only take 10 more minutes and I'll make sure you get something from this case study. So you can see that this is Aberdeen, okay? It's a place in, again, USA itself. You can see there's a river nearby, and this is the base station of the army, okay? Let us see what happens over here. Aberdeen Proving Ground is a US military arms weapons development and test center located on a military base in Maryland with no access to civilian non-employees. So normal public cannot go there. It was also used to develop and test some chemical weapons. And Aberdeen also had been used for the storage and disposal of some of the chemicals. So if you see, this was a place which is used by the US Army to develop and test chemical weapons. That means it used to deal with lots of chemicals. So in order to deal with chemicals, you need to store it and you need to dispose it also properly. So let us see what happens next. The case involves 3 people, okay? These are the 3 people. One of them is Carl Gepp, who was the manager of the pilot plant. The other one was William D., who headed the chemical weapons development team. And the third person was Robert Lenz. He was in charge of developing manufacturing of chemical weapons. So between 1983 and 1986, see, even the previous case study was regarding negligence, which was dated around the same time. Most of these cases have become very famous because we could draw a lot of conclusions from them. Now, inspections at the pilot plant said that there were serious safety hazards. Inspections were done and it concluded that, boy, there are so many hazards in this plant. These hazards included carcinogenic and flammable substances left in open containers, chemicals that can become lethal when mixed together, being stored in the same room. There were barrels of toxic chemicals that were also leaking. Also, the most important thing over here is an external tank for sulfuric acid had leaked 200 gallons of acid into the river. Basically, what here we are trying to say is that there were so many safety hazards, out of which most of them were, even if the chemicals were not being stored properly. Look at what's happening over here. An external tank of sulfuric acid had leaked so and so gallons of acid into water. In this case, it not only pollutes the river, it's a pollution to anything that is near the river. Maybe the animals drinking the water or the people using it for various purposes. Because of this triggered state and federal safety investigations that revealed inadequate chemical retaining dikes. Chemical retaining dikes are nothing but storage materials or devices, and a system for containing and treating chemical hazards that was corroded and leaking. In the June of 1988, the three engineer managers were indicted for the violation of RCRA, which is Resource Conservation and Recovery Act. RCRA banned the dumping of solid hazardous wastes and included criminal penalties for violation of hazardous waste disposal guidelines. So these three managers claimed that actually we thought that it was all going according to the conventional practices. We didn't know that it was illegal. See, the managers, as anybody would think, managers and engineers are responsible for building and testing stuff. But see what happened over here. They did not know the social science aspect of the situation. They didn't know that these accepted practices were illegal. So interestingly, since this was a criminal prosecution, why was it a criminal prosecution? Is because whatever they were doing could be harmful to lots of lives. The army also could not help the managers. They could not help them in the court. So in 1989, 1 year later, the three managers were tried and convicted of illegal storing, treating, and disposing of hazardous waste. There was no indication that these three were the real ones who actually handled the chemicals in an unsafe manner. But as managers of the plant, the three were ultimately responsible. What happened further? They got 15 years of prison and so many dollars of fine, 3 years probation, and 1,000 hours of service. Although we only have 100, they have 1,000 hours of service. Well, what can be the conclusions which we draw from this? I hope most of you would have understood this case study. Could we have someone from the audience who could speak out of what all they have observed through this case study? Let us have, I mean, you can speak out anything that you feel, but speaking out is important. Anybody from the audience? What have you observed and what could you conclude from this? Anyone? If not, I'll do it for you. No worries. Just wanted to know if you're aware of how to draw conclusions from this. Well, no worries. Okay. So what happened over here is, it was not these engineers who really did all these things. Okay. It was done by the people working in the plant. Now, these people did all these things. They did not ensure the safety of storing chemicals, etc. But finally, the managers had to take the responsibility. They were ultimately responsible for all these things. Although they wouldn't have done it, it is their duty to constantly inspect and to also make sure that whatever is happening is legal and is ethical. This is clearly, against the code of ethics also. However, we can draw a conclusion, a very interesting conclusion, that even though the mistake is not made by engineer, if it is made under the supervision of engineers, it can be equally costly for the engineers. So, as I said, engineers' works are out and open, and if something bad happens, he's damned forever. These three people were one of the most competent engineers. They were technically they were sound. But what happened, because they didn't know these things and they didn't even try to know whether this is correct or not. Because of this, finally they had to face the consequences. Friends, with this, I would like to send. I'm okay in the chat box. I have sent one Google form. Please fill it out. This chat box in this form will automatically take care of your attendance for this session. And there's a very small quiz also, which is being it's a very small quiz. Well, these are the conclusions which we draw from this case. Please fill the form and you may leave the session. Well, these are the sources from where I have taken all these images from. And once again, I would like to thank you for attending the pop-up course on ethics in engineering practices. You might be saying that why am I having only American cases? Why not Indian cases? Why are you bringing only cases from 1919, 1919? I would like to tell you, tomorrow's session is going to be the biggest session. It's having a case from our own country. Because of this case, it impacted millions of lives. Tomorrow's case will be the famous case of Satyendra Dubey. If possible, try to learn a bit about him. Tomorrow's case is going to be extremely interesting. And thanks a lot for attending this session. I hope I have been able to convey whatever I wanted to in at least decent manner. Thank you for attending the session, and I hope you are on the process of filling the Google Forms. Finally, the objective is to make each and every student conscious about this course. And although we have 10 students as audience, hope all of you can be epitomes of ethics in your future life. Let us continue the session tomorrow. It'll be session 2. I'll try to make it as short as possible, but tomorrow's case will be very interesting, believe me. With this, I would like to end the session. If you have filled the forms, you can leave the session. Thank you all again for attending the session.